Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aliya binti Mohd Rozi. I'm from AS251 4M1. I will explain about lab in Module 1. Lab 1, blink light emitting diode. The LED longest leg is positive while LED shortest leg is negative. For the first step, insert the black jumper wire into the ground pin on the Arduino and in the F33 of the breadboard. Second step is insert the red jump wire into pin of 2 on the Arduino and then the other end into I14 of the breadboard. Step 3 is place the long leg of the LED into I30 and place the short leg of the LED into I33. Bend both legs of a resistor and place one leg into G14 and G30. Last step is connect the Arduino Uno to the laptop using USB cable. This is the coding for the lab 1. Initialize LED built-in pin as an output pin with the line pin mode LED built-in output. In the main loop, we need to turn the LED on with the line digital right LED built-in high. The 5 volts to the LED N node that creates a voltage difference across the pins of the LED and lights it up. And when we turn it off with the line digital right LED built-in low. Step 2, multiple LEDs. For the first step, insert the black jump wire from the ground on the Arduino into the ground rail on the breadboard near J5. Then connect the orange jump wire from the ground rail blue line on the breadboard near J12 to H10. Then connect the red jump wire from the ground rail on the breadboard near J27 to H29. Insert the grey jumper wire from the ground rail on the breadboard near J47 to H48. Then connect the short leg of red LED into F10 and the long leg into E10. Insert the short leg of yellow LED into F29 and the long leg into E29. Then connect the short leg of green LED into F48 and long LED into E48. Then connect one leg of a resistor in E12 and the other leg into E26. Insert one leg of a resistor in E31 and the other leg into E45. Then insert one leg of a resistor in E50 and the other leg into E63. Connect the white jumper wire from 5 volt on the Arduino to the power rail positive near J3. And lastly, connect the Arduino Uno to the laptop using USB cable. This is the coding for lab 2, the multiple LEDs. Void setup will be executed only when the program begins, and the void loop means will be executed repeatedly. After completing the coding, we need to verify and upload the coding, and the output for this lab is the LEDs will turn on and blinking within in the sequences. And the output component for this lab is LED. Lab 3, red, green, blue, RGB common cathode LED. RGB LED common cathode have 4 pins. One share cathode connect to the ground and other 3 pins for red, green and blue connect each other of this through resistor to an Arduino pin. First step, connect the yellow jumper wire for the ground on the Arduino to the ground rail on the breadboard near A5. Step 2 is connect the red jumper wire from pin 9 to A31. Then connect the orange jumper wire from pin 10 to A35. Insert the white jumper wire from pin 11 to A38. Connect the green jumper wire from I38 to the ground rail blue line on the breadboard. Place one leg of a resistor in I31 and the other leg in E31. Then place one leg of a resistor in I35 and the other leg in E35. And lastly, place one leg of a resistor in I38 and the other leg in E38. Place red pin of RGB in the J31, the green pin in the J35 and the blue pin in J38. And lastly, connect the Arduino Uno to the laptop using USB cable. The coding of red, green, blue RGB common cathode LED. There are jumper wires that connected at pins 9, 10 and 11. After completing the coding, we need to verify and upload the coding. The RGB will light on in 3 colors: red, green and blue. The output component is RGB LED. Lab 4 tactile button with RGB LED. Firstly, connect the white jumper wire from the 5V on the Arduino to the power rail of the red line on the breadboard near A3. Insert the orange jumper wire from the 3.3V on the Arduino to the ground rail near A3. Then, insert the red jumper wire from the ground rail blue line near A5 to the H12. Connect the yellow jumper wire from the power rail near A23 to C27 on the breadboard. Insert the RGB into J54 for red pin, 1 share cathode on J55 for green pin in J57 and J59 for blue pin. Connect the black jumper wire from ground rail blue line near A47 to the H55 on the breadboard. Connect the resistor from H54 and the other leg in C54. Insert the resistor from H57 and the other leg in C57. Insert the other resistor from H59 and the other leg in C59. And lastly, connect the resistor from B12 and the other leg in B27. Then connect the orange jumper wire from pin 9 to A54 on the breadboard. Insert the green jumper wire from pin 10 to A57 on the breadboard. And insert brown jumper wire from pin 11 to A59 on the breadboard. Connect the red jumper wire from pin 3 on the Arduino into the H27 on the breadboard. And insert the tactile button from E27 and the other leg on F27. And lastly, connect the Arduino Uno to the laptop using USB cable. This is the coding for Lab 4. The void setup in the coding will be executed only when the program begins, and the void loop will be executed repeatedly. After completing the coding, we need to verify and upload the coding. Then to see the output, push the tactile button and the RGB LED will turn on, but in one color. So this lab is the red color of RGB that turn on. The input component for lab 4 is tactile button and the output component is RGB LED. For lab 5 is hear the beep sound. For the first step, connect the black jumper wire from pin 2 to B41 on the breadboard. For the second step is connect the green jumper wire from F37 to the ground rail blue line near from A34. Next step is insert the one leg of resistor into F41 and the other leg into C41. For the fourth step, insert the piezo buzzer into A37 and the other into A41 on the breadboard. And lastly, connect the Arduino Uno to the laptop or computer using USB cable. This is the coding for lab 5. The tune code embedded using code bender. It's simple tune, which is the buzzer sends a 1 kHz sound signal to pin 2 and delay 1000 that pause the program for 1 second, and no tune buzzer stop the signal sound. And the loop routine will make this run again and again, making a beep sound. And the buzzer is the output component. After completing the coding, we need to verify and upload the coding, and the buzzer will produce the beep sound. Lab 6 control servo motor using potentiometer. First step is insert the white jumper wire from A0 from the Arduino into F42 of the breadboard. The second step is connect the yellow jumper wire from 5V into the power rail near A48 of the breadboard. The next step is connect the red jumper wire from the ground rail blue line near A46 into F40 of the breadboard. Then insert the purple jumper wire from ground on the Arduino above pin 13. into ground rail, blue line near A34. Insert the green jumper wire from the power rail near A51 into the F44 of the breadboard. There are 3 wires of the servo motor. The brown wire is connected with black jumper wire into ground rail, blue line near A37 on the breadboard. The red wire is connected with red jumper wire into the power rail near A43. The orange wire is connected with orange jumper wire in the pin 8. Next, connect the pin of potentiometer into G40, G42 and G44 of the breadboard. And lastly, connect the Arduino Uno into the laptop or computer using USB cable. This is the coding for the lab 6. The input component is potentiometer and the output component is servo motor. Potentiometer is a simple knob that provides a variable resistance which we can read into the Arduino board as an analog value. Servo motor is a small device that has an output shaft. This shaft can be positioned to specific angular positions by sending the servo a coded signal. As long as the coded signal exists on the input line, the servo will maintain the angular position of the shaft. After completing the coding, verify and upload the coding. When turn the shaft of potentiometer, the blade at servo motor will moving. Lab 7, control DC motor and relay. Firstly, connect the orange jumper wire from 5V on the Arduino to the power rail near A58 on the breadboard. Secondly, connect the green jumper wire from ground of the Arduino to the ground rail, blue line near A61. Then insert the red jumper wire from pin 8 to B43 on the breadboard. Insert the jumper of 3 wire from relay mode 5V 1 channel, the black jumper wire to the power rail, red line near A39 on the breadboard, the white jumper wire to the ground rail, blue line near A41, and the grey jumper wire to the ground rail near A43. Then connect the white jumper wire from COM of relay module 5V 1 channel to the left side of control DC motor. Connect the grey jumper wire to the positive terminal of 9V battery. Place the red jumper wire to the control DC motor on the right side. Then connect the Arduino Uno to the laptop using USB cable. After verify and upload the coding, place the red jumper wire that connected with negative terminal of 9V battery. Controlling a relay module with the Arduino is as same as controlling an LED. The sketch starts by declaring the pin to which input pin of relay module is connected. For example, the relay pin for this coding is 8. In the setup function, we define that pin as being output. Now in the loop function, we turn the device on or off by pulling relay pin low or high respectively. Digital write 8 low pulls the pin low, whereas digital write 8 high pulls the pin high. For example, in this coding, digital write 8 high, serial print in off, delay for 1000, and digital write 8 low, serial print in on, and delay 1000. That's all from me, the explanation about lab in module 1.